Alright, today I'm looking at a 36401 Eclipse 4, 3 or 2 channel automotive power amplifier, and I bought it pretty reasonably. It's broken, doesn't work. It's got quite a few fancy features, as I would like to refer to them, but it doesn't seem to be working, so I'm just going to open it up and take a look at what's going on with this thing. So I've got this DC power supply. I'm just going to set it up for 9 volts and just a small amount of current, just enough to have it come to life, if it's going to come to life, but not enough to burn anything out. But it doesn't look like I'm shorting at all, because I just have a small amount of current coming in, and I guess that's kind of a good sign. So I'm putting in about 9.5 volts, and it's coming in. I've already checked the fuses, they look good. Voltage coming in on both sides of them, and it looks like then that comes through this power rail here, and it should be coming into these parts here then. So we should have our gate, our drain, and our source. So our drain, the source, so nothing's getting through there. And so these look pretty good. Yeah, so these parts look good, but there's nothing coming in on the gate. So I'm going to take a look at that. So we should be seeing pulsing on the gate, and we are seeing nothing on the gate. So on a drain we're getting 9 volts. And then on the gate, nothing. So that should be a pulse, and we're not seeing anything on that. So I'll look at what this chip's putting out. So the way I believe the circuit is working is you've got this transformer, that's going into a rectifier bridge that's producing our rail voltage. Rail positive and rail minus, and so you've got those MOSFETs driving current going into this. This might be a little bit different, but I think that's how it works. And then this chip here is pulsing and then pulsing in the opposite direction, kind of, through that other bank of MOSFETs. This is this DL494, and then you've got some kind of a feedback from somewhere in here coming back into the chip, and that's the input to an op-amp of sorts, and that's going to be the reference for these pulses. But we've got no pulse whatsoever, and on the gates of these MOSFETs, they're like switches, and electrically controlled switches. And so I'm going to take a look at this chip and what it's supposed to be outputting, what it is, and let's just take a look. So if I look at E1 and E2, or the emitters of the output, that's 9 and 10. I get 500. I get about 496 ohms and about 506 ohms. So it looks like instead of being to ground, they just got 500 ohms and 500 right here. So I'm looking at the pin 5, 3, 4, 5. And we're getting a 63.5 kilohertz signal or sawtooth wave, which this chip needs to be able to do the pulse width. And so that's looking good. But it doesn't seem to be, if I look at pin 8 and 11, 8's on. It's got full 9 volts coming out of it full time, which I don't think is supposed to happen. 9, 10, 11. And 11's on full time. So it looks like these two MOSFETs are driven by one line, and then these two MOSFETs are driven by a separate line. We can kind of see that by looking at the gates. Very little resistance between this gate and this gate, but a lot between this one, and very little between this gate and this gate. So these two are working together and these two are working together, and it looks like they're probably driven by these resistors right here. I'm wondering if these transistors here are driving these MOSFETs here, and so the signal's originating here, going through here, or it might be these here, I don't know, let me check. Very mysterious. I'm going to pull the board out and just see if I can figure out more. Okay, so I just did a little more figuring, and so it looks like the chip is supposed to be sending out a pulse here. It goes through a little resistor and then goes to the bases of looks like a NPN and a PNP transistor, and switches from ground to 12 volts, and so it's hard switching between the 12 volts and the ground, and then these are tied together and they're firing both of the forward MOSFETs, and this inside here is a transistor, and it's syncing, and so that there's another transistor right in here that's connected to the remote, and when the remote turns this transistor on, it provides a sink for powering these bases. And so if there's nothing on the remote, this guy doesn't go on, and so that this is still switching, but it's not doing anything because it's just pulled to ground. And yeah, so that's the circuit. The thing that I find strange is that this part's working right. When I hit the remote, all of a sudden this becomes charged up, and everything looks good in here. And so I'm really kind of suspicious of this chip. Okay, I just noticed that my current usage has gone way up. Let me put the scope on one of the gates for the MOSFETs. Try the other bank. Looks like it started working. Right, well, we see our little light on. What I was finding is this was the controller chip, and these resistors here almost seemed like they had a cold solder joint, and I fixed them, and then this controller started working better. It started bringing the power up, but then when I checked the power, it was we had a nice signal. Let me show you the signal coming into the diodes. Beautiful. There's the other side. So it looked beautiful, but then coming out of the diodes there was nothing. And so I took out these capacitors and I tested them, and they tested fine, so I put them back. And I took the diodes out and tested those, and those were fine. And still it was nothing coming out of the circuit. So shut this off. I just soldered in some temporary capacitors in there, and boom, started working. So these capacitors are clearly bad, so I'm going to order some new ones. So I've got these temporary capacitors in here until I can get the actual ones, and things seem to be working pretty well. If I look at my power rails, I've got minus 24 and 24 volts. And but something that's kind of strange on all the op amps, I've got minus 14 and 2.6, and these two transistors here are hot. And I think this is probably a voltage regulator for this part of the circuit here. And I think it's a kind of voltage regulator where you have a Zener diode, and that sets the voltage for all these other parts. And so I'm going to take a closer look and try to figure out. I think you probably want the power to be balanced in those op amps, but I'm going to take a look at it. So here's a circuit diagram from a power supply that's very similar, and what you're seeing is here they've got a rectifier bridge, but your plus 25 volts coming into this transistor, and that transistor is being regulated by this diode and the Zener diode. And here you've got the same thing for the negative rail, a transistor, and the Zener diode to ground is what's regulating the transistor. And so that's essentially the same thing that's happening on this power supply that's powering all these op amps. And really what I'm seeing is that a good voltage drop across this one, but not a voltage drop across that one. Okay, so if I go across, and I've got voltage set, and if I go across the one Zener diode, I have a drop of about 15 volts. If I go across the other one, I have a drop of 3.3 volts. So I don't know. I mean, I'm assuming that it's minus 14 and plus 14 volts that should be going into the op amps. There's just a ton of op amps on here. Okay, so I soldered the new Zener diode in and the transistor. And so let's turn it on. Okay, well that took me a lot longer than I wanted to. Originally I thought the one Zener diode was bad, and I replaced it, and then nothing was happening. In fact, it almost seemed like, yeah, so I don't know what was happening. I wonder if I put these transistors in backwards, because one's an NPN and one's a PNP. Anyways, it took me a little work, but now if I look at pin 8 on these op amps, I'm getting 14.7 volts, and the pin 4 I'm getting minus 14.26. Yeah, so now this power supply is working again. All right. Now I get to test out the amplifier part now that the op amps are working. Alright, so I have the amp hooked up to a dummy load. Just that big resistor right there. There's the amp. And I have it hooked up to a signal generator that's putting out about 300 millivolts, sine wave, 440 hertz. And you can see on the scope the wave looks really nice. And this is just one channel, and I don't have it hooked up to a very big power supply, and I don't have all the heat sinks in, so I don't want to push it too hard. But if you look at the FFT of it, it looks nice and clean. There isn't any distortion in there at all. And so I'm pretty happy. Looks like I'm making progress. Okay, so I've got this car battery hooked up to the amp. I wasn't able to get enough power with it otherwise. And I've got a 1.3 volt peak-to-peak 440 hertz signal right here coming through to the input to the left channel. So I'm going to connect up my power. Get our green light, and we can see that we have a signal coming out, and I'm just going to turn it up here. And then I'm going to turn it up over here. Okay, so we're putting about 1.4 volts into it, peak to peak. And I'm going to turn it down till it just not getting any distortion. And so we've got a 13.35 RMS voltage. So if I take my calculator, so 13.35 times 13.35 divided by 8 because I don't have a 4 ohm load, I have an 8 ohm load. And we get about 22 watts. Yeah, 22 watts. So it's not a huge amount of power, but this is rated for a 4 ohm speaker. And I'm running at 12 volts, not the 13.8 of a car. Nothing's getting warm, or it shouldn't at this rate. So there you have it, a nice old school Class AB amplifier back and running. Looks like it's about 50 watts per channel into a 4 ohm load. Alright, so I have it hooked up to some speakers. It's pumping pretty good. Anyway, so that's my repair video for this 36401 Eclipse AB amplifier. Sounds pretty good. I have it hooked up to the speakers, and really pumps out the sound, I think. Anyways, if you liked the video, please subscribe. Thanks.